Okay, welcome. Let's see how we can now use the tapply function in the context of trying to set up a frequency table. So let's say we've got some numeric variable, like it's a continuous numeric variable, but we want to count up like how many occurrences fell between one bin range, how many occurrences fell between a second bin range, and so on. So it's like calculating the heights for each of the bars that we would use in a histogram. And so the first step of that process of creating a histogram is first figuring out what your bin ranges are, and then sorting the values into each of the bin ranges, and then counting up how many values were in each of those bin ranges. So let's work with some data. We're going to work with a data set called Faithful, which is in the datasets package, which is already installed and loaded in Colab. So you don't need to load the datasets package. It's already loaded. So you've got access to the Faithful dataset already. And the Faithful dataset contains 272 observations based around eruptions from the Old Faithful geyser in Yellowstone National Park. So a geyser is just, we've got like water, which is extremely hot and then shoots up out from under the ground every so often. And Old Faithful is this classic geyser in Yellowstone. They call it Old Faithful because it is supposed to be very predictable in terms of how much time elapses between subsequent eruptions. So this data frame, for each eruption of Old Faithful that is recorded in this data frame, we've recorded how long the eruption lasted in minutes and how long did it take from when that eruption ended until the next eruption began. So that's what we'll call waiting. That's how the wait time between subsequent eruptions. So we'll focus on the eruption variable, and let's extract that variable from the Faithful data set, and we're going to store it as a numeric vector. So this first code cell, that's what we've done. We've stored the eruptions variable into a vector now. So now we've got our data stored in a numeric vector. The next step would be to think about what are the bin ranges that we want to use. And that depends on how many subintervals we want to break the data up into. So we're going to use the pretty function to determine these breakpoints. So the pretty function takes two main arguments. We need a numeric object where all of our numbers are stored. So for us, that's going to be the numeric vector eruptions. And we also need to specify how many intervals do we want to be created. So let's say we want 10 intervals created, and we want to kind of break up the eruptions into 10 nicely sized intervals that have nice, pretty breakpoints. And R is going to do its best, and it might not be possible. But the point here is I want to get nice rounded endpoints for my bin ranges, as opposed to like really messy looking decimal values. So we'll run this code cell, and what we get are 9 breakpoints. So we go from 1.5 to 2, 2 to 2.5. So we're going up by half a unit increments, which is a nice round number, until we stop. The last interval would go from 5 to 5.5. So these 9 breakpoint values give me 8 sub-intervals. I've got my first one from 1.5 to 2. My second one is 2 to 2.5, then 2.5 to 3, all the way up to our last bin range, which is from 5 to 5.5. So those are going to be our breakpoints. And now what we would like to do is count up how many eruptions lasted between 1.5 and 2 minutes. How many lasted between 2 and 2.5. So we have nice rounded breakpoints. we have bin ranges that have nice widths, half a minute in width, and we've got 8 intervals instead of 10. So if it set up 10 intervals, it would have had messier breakpoints. So that's why we didn't quite get 10 intervals. We got 8 instead. So we're going to use the tapply function to count how many values occurred in each interval. But the first thing before we do that, we need to set up a new variable, which is going to indicate which bin range each value fell into. So we're going to create that variable using a function called cut. So this function cut has 2 primary arguments, which is a numeric vector. For us, that's going to be the eruptions. And secondly, we need to input a vector of breakpoints. And this is what we got out of the pretty function. And then what this function is going to do, if I just take a look at the first couple of entries in eruptions, it's going to say 3.6. 3.6 falls in the bin range from 3.5 to 4. So its value of the variable interval labels would be the bin range from 3.5 to 4. Then it's going to go into the next value of eruptions and say, what is the bin range that 1.8 falls into? And that falls between 1.5 and 2. So for each value in eruptions, it's going to assign a value of another variable that we call interval labels, or a vector that we call interval labels. So I'm going to run this code cell, and we can see that it's saying 3.6 has an interval label value of this bin range from 3.5 to 4. And we're making this right inclusive, left exclusive. So if there were an eruption that lasted exactly 3.5 minutes, it's going to fall in the 3 to 3.5 range and not the 3.5 to 4 range, because here we are excluding the left endpoint. That's kind of a subtle issue here, but each of these values, none of them occur at one of these endpoints. But if they did, I just want to explain how that would work. But the 3.333, that falls in the range between 3 and 3.5, and so on. So now we are assigning an interval label to each value in eruptions. And this vector interval labels has the same length as the vector eruptions. So now we're ready to use the tapply function. We have this data stored in 2 separate vectors as opposed to columns of a single data frame. But the first vector that we want to apply the tapply function to is the eruption time. So we've stored those in eruptions. And then what we're going to do is we're going to use as an index interval labels. So for each bin range, it's going to split up the eruption times. It's going to group them into different bin ranges. And then the function that we're going to apply to all of these eruption times is count up how many are there. So we're going to apply the length function. So you can imagine we've got all of these eruption times. It's going to group them by the interval label, by the bin range that the value falls in. So then we're going to get a bunch of eruption times separated out into these different bin ranges. And then we're going to apply the length function to each of those bin ranges, which is going to count how many eruptions occurred in each of those bin ranges. And here we're going to store that result to a list that we call count. And now you can see this is saying 55 observations were greater than 1.5 and less than or equal to 2 minutes. there were 37 eruption times that were strictly greater than 2, less than or equal to 2.5, and so on. So that's how we could use the tapply function to set up bin ranges and then count up how many the frequency of observations in each of those bin ranges.